Un, deux. Test.
应该是这个。他们两个没有来。
OK， 因为可能还是3台吧，它一个开关可能3台的吧。OK， 那我们就先开始了。Okay, ladies and gentlemen, let's start today's class. This is second week. So this week and next week, we're going to talk about the introduction of biosystems engineering. So this week will be shared some research experience and the scope of this area to you by me. And next week will by Professor Yan. And then the first week, 1 week before, the joint class together with Japanese universities, and we are talking about the trend of technology development. And so let's start today's lecture. And all the lectures today, I have uploaded to the SEBA, the teaching website. Okay. Okay, introduction of biosystems engineering. Here's main domain, and just from the scope of the my department. Okay. Let's see. Okay. Okay, good. Now I have the laser pointer. So the main domains listed here is from the view of my department, and for our brother department, they may have more domain in the environment. And so the first branch is the machinery and system. And I would like to invite you to discuss what mean to you, say, machinery and system. What's the difference between machinery and system? Anyone would like to elaborate on this issue? Yeah, this discussion, so anything. Anyone? Yes, please.
I'm gonna try, but I'm not sure. Maybe system is more autonomous than machinery or something like this. I don't know. System is more complicated, maybe. I don't know. I try.
Okay. Any more comments? How about you? You want to say something? Please use your microphone.
I think system is more bigger than machinery.
Bigger, okay.
And machinery is like mechanical, something like that. And the system combines control and sensor, something like that. So I think system is more bigger than machinery.
Okay. Both of you are correct. And I may add some more comments. Machinery or technology together. And machinery can stand alone, and systems may be the integration of many things. So machinery could be part of the system. So you say the system is bigger, yes. And nowadays, the machinery is not only mechanism. And all the machinery you see today will be coupled with some kind of control, either computer control or electronic control, and some other kind of communication even nowadays. And so systems, for example, you have the drying systems, the drying system for grain. So not only dryer itself, it could be many dryers together, integrate together, and not only for dryers, but also, they need some husking of the rice before the drying first, and then after that, you need to dispose those husks, and also the storage after drying, you need to send it to the storage bin, storage tank, or storage facility, and so that's kind of drying system compared to dryers. Okay, dryers in Mandarin 干燥机 drying system is 干燥系统. So system is bigger, yes. And how about the measurement and control for the second issue? Measurement and control. Can you make any control without measurements? We have the freshman, the youngest student in the class. Yes, please use your microphone.
I think measurement is you want to know the object and you want to know maybe the information about its position or velocity, and control is you need to do something to make the things do what you want it to do. Is the difference. But control needs accurate measurement. It can do the much better. Control depend on accurate measurement.
Okay, you're right. Basically, the control is based on the measurements. Without measurement, you cannot do any control. For example, you want to control the room temperature in the room and by air conditioner. And if there's no sensor in the air conditioner, how can you make the control? Because you don't know the temperature in the room. So you will set the the temperature and set the temperature you want in the computer. In the controller of the air conditioner, and then compare the temperature setting with the temperature in the room, and then you can just so there could be some difference between the temperature here in the room and also the temperature setting in the air conditioner. So you can adjust the environment, the temperature in the room by either turn on the compressor. There's a compressor in the air conditioner. So usually only the fan circulation. So when your temperature higher than the setting temperature, then the compressor will working and to give you the so-called air condition, cool air in the room. So that can reduce or cool down, reduce the temperature and cool down the room. So that's for very easy example, very common access the example in the life. And in science or in engineering, also without the control, without the measurements, you cannot make a control. Or without accurate measurements, you cannot make it a better control. So measurement and control is very important. So that could be the eyes of our human beings, and control could be the decision and action of our human beings, the brain and hands. Okay, so it's robot. Usually the robot considers 3 elements. One, the sensing. For example, eyes of a human being, and decision making is, for example, the brain of our human beings. And then what do you see, and then you make a judgment, and then you need to do the action. So the action, just like the hands of feet of human beings, is action. So 3 elements is needed to build up a robot system or mechatronic system. Okay. Materials and process. Any people would like to comment on this? Say something you want to. What do you mean to you, materials? I think you can say something about materials.
Well, the materials are the things that you are going to use in the process, right?
Say it again. I beg your pardon.
The materials are the things that they are going to be used in the process.
In the process. Okay. And more? And
the process is like a step-by-step thing.
Okay. Okay. Good. Any more? Materials. You do some biotech, right? So you have some material to say something.
I think that process is a combination of materials. I mean, materials are a part of a process, and I mean, it's very large as a subject. So I don't know exactly what to say about that, but just to say that the process is a combination of some materials, and materials are just
is there a microphone?
Just what you need to do the process, and without materials, you cannot do the right process if you don't have the right materials.
Very good. The process here could be food processing, so it means you can process food from the raw materials, and you could be some kind of process for the control. But here, the third category here is more or less related to bio or chemical related process, not a control process. If control process in the second category, there's a control should contain that part, and the material could be something raw material or something you would like to make the new. For example, the chitin, a material called chitin is from the shell of the shrimp or crabs, chitin. But the chitin actually is kind of waste from material point of view. So you see, throw away the pier or the shrimp after you eat the shrimp or the crabs. But the chitin, you do some kind of processing, you can convert from chitin to chitosan. And chitosan is good for many applications, especially for medical applications. For example, the soldiers in the war, you know, there's gun, there's cannon, and bullet, and so usually you will get hurt, and that kind of the injury involve the breathing. So although there's a hospital in the front site, I mean, but there's still some distance to transport this injured soldiers to the inside the hospital. So the first thing you need to stop breathing. Many soldiers die not because the injury is that serious, because breathing too much. So the chitin could be used to weaken a kind of wrap to stop the breathing for medical purpose. So from a kind of waste, the chitin, you transfer to or make some process to chitosan, and so chitosan can used for many kinds of medical applications. One of the breathing wrap for soldiers for surgery in the hospital is one of the examples. Okay, so machinery and system, measurement and control, materials and process, basically three main domains in biomechatronics engineering department. Okay. And what are differences between biosystems engineering, biomechatronics, biotech, and life science? What are the differences? Of course, there are some overlapping. Some of them are overlapping, and some may be pretty different. Say something. I think this is free talk. Many things can be mentioned.
Oh,
okay, good.
Okay. So biosystem engineering is more related to agriculture and using of mechanical things. I mean, it's the engineering more about biosystems, so more about environment and agriculture, I think. Biomechatronics, that's a good question. I don't know exactly what it is. I would say maybe it's more related to ships and something like that. I don't know exactly. Maybe you will tell us after. You will tell us after. And biotechnology is the technology related to the life science. So is the use of technologies for to find new processes for the or which is related to the life. So for example, biochemistry, microbiology, there's its applications of biotechnologies.
Mm-hmm.
And so life science is more the study about the life, and it's maybe less. It's life science is more global, maybe more general. So
okay. You want any comments? Good.
So maybe for me, like biosystem engineering, it's like more global, and in bioscience, in biosystem engineering, you have like biomechatronics and biotechnology, and to do biosystem engineering, you use life science.
Okay. Okay. Good. More input? You want to add something? Good.
Like them said, biosystem is more like agriculture, and I think it has environmental control inside. Like I think plant factory is some kind of that, and biometronic I think is a combination of biosystem and mechanic and chemistry, I think. And the biotechnology is more similar to life science, and it focuses on chemical and the virus research. And the life science is more focused on the life things like animal or the plants or something like that.
Okay. Okay. Good. Any input from two gentlemen here?
Just like them say, biosystems engineering is more related to agriculture, and biometronics maybe is some machine to do the agriculture, and biotechnology is maybe someone makes some medicine or something healthy. Life science is like some I don't know, just the combination of all these.
Okay, thank you. Biosystems engineering, many people mention, and for current situation, you are right. More agriculture application are emphasized, but it's not limited to only agriculture. And because agriculture only part of the biosystems. So environment, medical, and should medical, medicine, and so biosystems engineering, the system is very big. So ecosystems, environmental issues are related. And biomechatronics could be more or less concentrate on the mechanical and mechatronics. Mech means the mechanical, tronics means the electronics. So biomechatronics means we use the biomechatronics technology to bio-industrial, biofields. Biotech could be many things. We just mentioned from the chitin to chitosan, and actually it's biotechnology. But why I mentioned that in this class for chitin transformation of chitin to chitosan, because what's the definition of chitosan? That actually is a transfer rate from a chitin, the waste from the shrimp, the shell shrimp or crab, to chitosan. The transfer rate is very important. For example, you may only require by the market only 40% transfer rate. And then if you did not make any control, and then transfer rate may be 35%, and then your product is not qualified to meet their consumers' requirement. So we need to make some kind of measurement to see how much process have been done, and what degree of transfer rate is there already, and then you make a control. And anybody here, the control theory called PID control or some kind of fuzzy control. So measurement and control could be connected with the biotechnology. And the sensing technology used for transformation from the chitin to cytosol is near-infrared. Infrared is the wavelength beyond 700 nanometers. So we had a visible light, right? So the wavelength longer than red light is infrared. And because the range of infrared is so big, and near infrared means they are near the red light, the part near red light. So usually from 700 to 2500 nanometers. Eyes of human beings can see is 400 to 700. And then beyond 700 to this part here is infrared. And for near infrared is only from 700 to 2500 nanometers. So I use a near infrared NIR to measure the transformation of chitin and to see the degree of the transformation and make some control of the speed of process, so to get the cytosol as a target. Okay. All right. I think I pressed this already, right? Okay. So and life science may be even bigger. So in my department, although many professors, most professors do many things, do many research on mechatronics, but still some professors doing life science area. For example, DNA in my department. So you can hardly believe they are DNA and mechatronics, but still they use the nanotechnology to manipulate, for example, fluidics to control some kind of on-chip measurement, on-chip lab on-chip system. And also some people like Professor Ho Yong, he do something on stem cells. So the life science. So even in my department, more or less mechanical oriented, but still life science is part of the research area or teaching area of some professors. Okay. Okay, so basically it's kind of a multidisciplinary program. So not only one topic, it's multidisciplinary. And multidisciplinary is very important nowadays for students or for the class university teaching, because the society nowadays require more kind of different background, the people with the background like that. And so it's kind of engineering integration for application to bioindustries. So bioindustries could be anything related to bio. So agriculture is one of them. So that's why I say industries. So not only one, is more than one, so industries. And so multidisciplinary program is very important nowadays, and also in this kind of departments. And here I give you some kind of background I have as an example. I have research and also I explore some of the area in the computer simulation and control. For example, I to CFD simulation in order to know the pattern, environment pattern in the greenhouse. Okay, so we like to know which part is warmer, which part is needed more no wind, more wind, ventilation. And so, or which part the lighting is not sufficient. And so, in order to control, and why we need to simulation and the measurement, we are talking about measurement control. Why computer simulation and control? Why don't you measure it and control it? Why you need to use a computer simulation? When you make a measurement, what do you need to pay for it? Another cost. For example, you want to measure the temperature inside, temperature distribution inside a greenhouse. You need many temperature sensors. And actually, it's very expensive, very costly to do so. So usually nowadays, even in Netherlands, it's claimed is the strongest country doing with the greenhouse. Still only a few temperature sensors, humidity sensors, and lighting sensors in the greenhouse. So how can you tell us your measurement is representative of your greenhouse condition? And so if you do it, then it's very expensive. And computer simulation is I set a theory and use a CFD, for example, to make a simulation. Of course, I need to verify the results. So I still need some measurements to test or to match or to modify the computer results, the simulation. And then with that, for example, I can make some kind of arrangement of the greenhouse. So for example, I can put more fans here or there, and then can make the temperature distribute more even. And then the control will be much easier with the simulation or cheaper with the simulation. So computer simulation, measurement and control are together. And they have their different kind of opportunity to use. And artificial intelligence, AI. Nowadays, many people working on AI. AI is kind of a hot issue for recent years. And so mechanization, automation, now it's AI. And for example, I use the computer imaging vision. Our TA working on that to identify the wheat and the vegetables, crop and the wheat. And computer vision had been there for many years, but use CNN or so-called deep learning, convolution neural network, or deep learning technology with computer vision, then you have better ability to recognize the wheat from the crops. So AI is one of the my expertise in this area. I just give you some example of my expertise to discuss. So biosensing, I use the near-infrared, basically, or fluorescence sensing to biosensing of the biomaterials, sensing of biomaterials. And for near-infrared is a spectral, and combine the computer vision together, you will get the spectral imaging. So not only the wetlands, but also the spatial vision. Later on, I will give you an example of the tea fermentation to show you how can combine spectra and the imaging together. Remote sensing. Remote sensing, many people are thinking about maybe from the satellite, you make a remote sensing. But basically, if not directly contact for sensing. For example, I would like to measure how firmness of your arm or your muscle. I may press your muscle and see how your response on the muscle. And this is not a remote sensing, that's touched. And so you will hear about some kind of non-destructive measurement, non-invasive measurement. Non-destructive means you don't need to destroy the sample, you just measure it. The near infrared is one kind of technology, could measure many things without destructive the material. For example, you want to see or you want to know how sweet the fruit is. The common way or the traditional way, you take one drop of the juice and use the meter to determine how you say that, the degree of sweetness. Brix, right? BRIX, Brix, to see. And now we have a digital meter, you can measure bricks, but still you need a juice. So juice is destructive of the material. You need to cut the fruit and take squeeze the juice and then put in the meter in order to measure it. But near infrared, you don't need to cut the juice, the whole fruit, and then you shine the near infrared, I mean the light into the fruit, and then from the response of the light, you will know the sugar content, you will know the acidity. So it's non-destructive. How about non-invasive? Non-invasive control. It means we don't need to contact you the sample, so it's non-invasive. So the remote sensing is not as far as from the satellite, actually from something on the Earth, it still can do the remote sensing. Some distance away and then make a measurement, and it's called remote sensing. Okay. Okay, so here is some kind of the subject fields and for you to refer, but not only limit to the items list, but here I would like to show you what I see in this area, and also some of them also the subject field also listed in the ISME conferences and also the EAF journal. So bioenergy and renewable energy is one of them. And here I use alphabetic order. So you see bioenergy is the first one. And biological and biomedical engineering, biomechatronics and robotics, power and machinery, food engineering, information and electronics, post-harvesting technology, precision agriculture, sensor technology, structure and environment technology, and waste management. And I think still some more as time going. So that's not fixed. For example, the AI I did not put here, right? So AI now just recently received many much attentions. Okay. All right. Or anything you want to add? You want to add something? you can think of. Okay. All right. Okay. And I think this is the last slide. Yes, this is the last slide. Oh, you want to say something? Oh, okay. All right. When I was a child, I played this toy very often, and to people together and try who can make it how you say that higher. So you make a competition. So I use this slide means that technology is growing and growing and higher, and hope someday we still at top of technology for the students from the National Taiwan University. Okay. Okay. And so after this, then I will show you some examples. Which example you want to see first? Let's see. I think I don't want to repeat this slides, but I already put this slide on website and plant factories. I will show you one movie, very short movie, how we grow the lettuce in a factory, in a plant factory. So I think we discussed on this PowerPoint or this subject some part last week, right? And so I don't want to repeat it. I just show you the first slide, and then I will show you the movie. This growth of the lettuce, you see they grows bigger and bigger. One layer of the sticks. And the reason I show you this movie, you want to see it again? You can see lighting sometimes on, sometimes off. And sometimes only part of the tubes are on. And this time all the tubes are on. And so they relate to three things. In order to let the crops or plant, or for example, lettuce to grow, the lighting condition need to consider these three kind of items. The first, light quality. And it means what kind of wavelengths will be good or will be most appropriate for the growth of lettuce. And of course, the sunshine, right? The solar lighting is suitable for all kind of vegetables, but actually they are only red and blue. These two wavelengths are most important. And what's the ratio of the blue and red depends on different crops. So in the plant factory, the control of red lighting and blue lighting is very important. Okay, so that's called the quality. This means which wavelengths you are going to be used for the plant factory, for this crop. And intensity, how strong the lighting is. Okay, so in order to get enough, so you see sometimes it's only 3 tubes and sometimes off, and now it's there, or lighting is on. That means the control intensity at different growth period. Okay, and what's the period? That period, just like we human beings, we need to go to bed to sleep, and in daytime we need to be active. So the vegetables, I mean the crops, also need to sleep. So you cannot shine the light all the way 24 hours a day. You need to make some period, is dark period, for them to rest, for them to sleep. So these 3 kind of control parameters are important to grow in the not a greenhouse, they are plant factories. And also see the 19 tubes there. That 19 is same as this one. This is called T5 tube. T5 compared to T8 is more energy saving designed. Of course, more expensive, but you can set, the regular tube is called T8. For example, 10 years ago, there's no T5, only T8, and it's big. I mean, the diameter is bigger, and also the shape like this, but it's consume more energy. So nowadays in NTU here, you will see, I would say 99%. I'm not sure 100%, but I would say most of the classrooms and offices or change to a T5 tube, fluorescence tube, and that's a T5. But you may hear about the LED is kind of also a lighting source for artificial lighting. And yes, LED could be controlled red and blue more easily. You can use red LED, blue LED, okay? And then, but the problem is LED is expensive. And although expensive, but its energy savings much better compared to the T5. So
maybe
also,
yeah, maybe we can keep more longer the LED compared to the T5, right?
I can keep what?
For a longer time, the LED.
Longer time, yes. LED also takes longer time. So you need to figure out in the long term which one is more cost effective. Yes, and so there's longer, and also save energy compared to T5. And also LED's a major advantage is the lighting is cool, the cool lighting. For example, if you touch the tube, be careful because it's very hot. But you touch the LED, okay, it's warm, is not that hot. So it means the vegetable can grow a little bit higher. So it means that the clearness or the distance between two layers could be shorter. And so the same roof height, you have more layers to grow your vegetables or lettuce. So thank you for your comment. Yes, it is, that's longer. 比较耐用, that's longer. Okay, any more questions on this movie or PF, Plan Factory? Okay, all right. So let me show you another examples. How about tea? All those lectures, I mean, PowerPoints already on the SEBA system. Do you have chance to access the SEBA system? Okay, good. And as I mentioned last week, since this week on, the class begin 9:30 until 11, no break in between. However, you want to go to the restroom, you want to go out to have some drink, you are welcome to do it anytime without notice me. Okay, notify me. Okay. And I try to show you that what the application of spectral imaging to evaluate the degree of tea fermentation by total catechins. Okay, this chemical, this a very good component in the tea, and it's good for your health. And before I talk in this, I will jump to some slides afterwards. Let me ask you a question. What kind of tea most popular in Taiwan? You may know, you may not. Oolong tea. You tasted oolong tea before? Oolong tea. You tasted green tea before in Japan? From Japan or in Japan? And what kind of tea in England or Europe? Usually, there's black tea. Black tea. Usually, UK related countries, they produce their black tea. For example, in India, Sri Lanka, Malaysia, they drink their black tea, 红茶 black tea, 不是叫黑茶，红茶。In Taiwan, we say 红茶 means red tea. Actually, it's not red. The color is red, but in English, it's called black tea. Okay. And then in Japan, they commonly use the green tea. Okay. In Taiwan, usually you get oolong tea. What's the difference between these three kinds of teas? Black tea, green tea, and oolong tea. It's based on the fermentation. So green tea is unfermented tea, no fermentation at all. Green tea, no fermentation. And black tea is, so on the other extreme, black tea is totally fermented, fully fermented. And how about oolong tea? Oolong tea is kind of the name, the brand name of the tea in Taiwan. Actually, we have baozhong tea and many kind of, but just take oolong tea as an example. It's partially fermented. So in between. So informative, we say material and process, right? We just discussed about material process, right? So tea is material, and the process is fermentation procedure. Okay, so unfermented tea is relatively easy because you just kill the enzyme at a very early stage and start the fermentation. So that's what the green tea making process. And for the black tea, it's also a kind of easy because just that fermentation going on all the way to the end, and that's the black tea. Partially fermented tea is kind of difficult because you need to control degree of fermentation. And so this factory may be 45% degree of fermentation. That factory may be 30% of fermentation. So it depends. So different flavor. So the research I have shown you is use the near infrared spectral imaging to determine or to evaluate the degree of fermentation. Now, but before that, I would like to show you the process we just discussed of fermented tea. So the pumpkin, the tea leaves from the twig first. Okay, this all the same for all kinds of teas. Okay. And then penning. And penning usually use hot air to kill the enzyme activities. So you know, after planting, after you pick the leaves from the trees, tea trees, and then stop the enzyme activity immediately. So there's no fermentation oil going on. Okay. And then rolling is make a shape on the leaves, and then drying. That's all. So it's relatively easy for fermented tea, for example, green tea. Okay. All right. And how about the partially fermented tea? Cranking, of course, the first step. And then withering under sunshine for some time, usually less than 1 hour. For example, 20, 30 minutes. Okay. And then after, that's the fermentation process. You set in there, you stir in and recycle as many times as you want to control the degree of fermentation. So fermentation process will occur in this process. The stir is to stimulate the fermentation process. And then if you stimulate the fermentation and set in there still, one step may be for 1 hour or 40 minutes. And then after 1 hour, 40 minutes, and you stir it again. And the more stir and setting you repeat it, the more degree of fermentation will happen in the tea. Okay. Then after that, penning. Penning is a process to kill or to stop the enzyme activity. So at this stage, the fermentation ends, stops. Okay. And then after that, rolling and drying. So major difference thing is here. Some people even try to omit this process, but this depends on the flavor. So you have some solar withering, the flavor may be different. You have a question?
Yeah. Why we must to do the second step for the fermentation? I mean, what is the aim of the second step, the solar withering?
You mean the fermentation process?
No, just before.
flavor. I mean, whittling the solar wind. Yes, I use. So some people would like to consider to stop this because that's the difficult to mechanization, and this could be mechanized.
Yeah, but I mean, what?
How you control the degree of freedom?
Yeah, no, I mean for the solar withering, how makes the flavor different?
The stirring here actually is the break. When you stirring, somehow you will damage. I would say little damage. I mean they break the leaves, so they will call the fermentation. And the problem is we say measurement and control, right? How you measure the degree of fermentation? Unfortunately, nowadays, by the expert, smell, feel, it's not the it's not the subjective. It's very objective. So that's why I try to use a near infrared scientific approach to help them, not to replace them, to help them to decide, to know the degree of the fermentation.
Do you have to control the temperature and the atmosphere during the fermentation? I mean,
yes.
How much the temperature and the
humidity
must to...
Yes. Of course, here also the temperature and the humidity need to be controlled, but no lighting. We don't need the lighting control this part. Only the light is enough for you to see. That's okay. But yes, you are right. Thank you for the comment. Temperature and humidity control also needed for the fermentation. And so this is the most labor-consuming work. But unfortunately, nowadays the in tea industry in Taiwan is the way like this, and the control. I mean, the measurements by experts, smelling, feeling, and to feel. It's about right, and then stop. And this is not accurate at all. And so why this research going on? And how about the that's the oolong tea, for example. And then another is the fully fermented tea. Of course, you need to planking first, and then setting there for 24 hours. And rolling. So the fermentation occurs in this part. And then setting another 3 hours wrapped by wet cloth. And you get final setting. After the final setting, you get a product like that. And enjoy. Because it's fully fermented, so there's no panning needed. Remember, we use the panning to stop the activity of the enzyme, right? Okay. So there's additional information for you to understand the tea process for green tea, oolong tea, and black tea. Okay. All right. So now we can go back to our beginnings. So in this study, evaluation of degree of tea fermentation by using a spectral imaging approach is the main issue. Okay. Tea is one of the most widely consumed beverage in the world, only second to the water. And I think the coffee is after drank after tea, and different from black tea, fully fermented, and green tea unfermented. Baozhong and oolong tea are partially fermented teas, which are popular in Taiwan and Asian countries. Okay, and so because it's partially fermented, so degree of fermentation, DTF, is usually regarded as index of quality assurance during the process of partially fermented tea. And what we need to do is use the total catechins content, TCC, because it's highly related to the degree of tea fermentation. And so DTF here use the content of the chitin. So maximum minus chitin at the current status. So the definition of DTF is something like this. So this definition, but in the old days or traditional way, we need to make chemical measurements of the chitin's content. And near-infrared, I just mentioned, is the non-destructive, non-invasive, also is rapid. After you develop the model, I mean the calibration curve of near-infrared, it takes only a few seconds to get the results. You do the chemical analysis, probably need a couple of days. And then remember, the fermentation process is going on very fast. So you cannot wait a couple of days to get the results. So that's why in the industry, tea industry, you use the experts' experience to feel, to smell. Okay. And actually, when you feel, you smell, it's kind of sensing, but it's the biosensors equipped with our human body. That's all. But as I just mentioned, it's not a subtractive. It's not objective. It's very subjective. Okay. It's very subjective. Yes. And okay. And HPLC or CE was commonly used for the chemical methods. Okay. And it's not only destructive measurements, also it's time-consuming measurement. I mean, need a couple of days. So spectral imaging could be used to measure the integrants of the status of crops and biomaterials. So we're trying to build a fast, non-destructive approach to evaluate DTF using hyperspectral technology. Hyperspectral imaging. Hyper is many wavelengths. USC two terms. One is hyperspectral, and another is the multispectral. Multispectral is a few, for example, 3 or 5 wavelengths. Hyper is many, for example, 10, 20, or even 100 spectra. Okay. All right. And you have questions?
It just was, yeah, for this part. The measurements here are after the process, right? You cannot do that during the process because HPLC method.
Online. Online. The approach here, the hyperspectral imaging technology, is online. On the process. During the process.
Yeah, okay, but
not after. If the chemical analysis, you need to.
Yeah, because electrophoresis and HPLC, it asks a bit of time to do it. So
yes, that's why we cannot use it because we need it online.
That's the okay.
Yes, good comment.
So you cannot.
Good comment. Why we need to do this? Because HPLC or CE is a chemical, is wave chemistry method. So you need to do it in a laboratory, and also it takes some time. So that's we cannot do it online. So it's not suitable for online process monitoring or DTF. Okay. So we need to do the spectral imaging technologies. Okay, and I just show you that, right? I just show you the process of from tea garden to tea drawing, and so 97 tea leaf samples with various degree of tea fermentation were collected. Okay, I think this is repeated. You already know this. Okay, so that's the hyperspectral imaging system. So we have the visible wavelengths, we have near infrared wavelengths, and then your CTS liquid crystal tunable filter. So use your CTF, we can adjust different wavelengths. Okay, and then hyperspectral imaging and so on. Oh, here. LCT is liquid crystal tunable filters. Okay. So I just show you, okay, we take sample this and this sample number, and this is calibration plate. Okay. So we put them together so we can make calibration at that time. And then you take different wavelengths. For this case, we from 400 to 1100 nanometers. And on this axis is wavelengths. And so for example, there's G and the X and Y axis, this is spatial. So you can know any place, two-dimensionally, any place, the T at any location, the response in terms of spectral. Okay. So for example, location A, there, you get spectral from 400 to 1100 nanometers. For example, you get a B, you want to point location B there. And then, so you get all the information, and then you make an analysis. Then just to show you what TCC, the chemistry analysis of TCC. Why we need to mention this? Chemical analysis still nowadays is a standard method. And optical method, we use the near infrared, is the alternative method. We're trying to use optical method by near infrared to substitute the standard method. So you need to compare this method with the standard method by wave chemistry. So still we need to, for this case, we need to measure TCC by wave chemistry at the same time. Okay, so you see, first of all, you need to destructively ground into the powder and then dissolve in the iron water and shaking in the 80 degrees water beds and tea solution by filtration, and finally by HPLC. Okay, it's very labor consuming and also time costly. Okay, and spectral analysis use the WinSI for near infrared system, and so two methods. The regression method we use is MPLSR and MLR. Okay. And here you see the wavelengths and also the correlation coefficient for calibration and also for the validation. And standard error of calibration, standard error of validation. And RPD is the index. RPD, higher RPD value means better performance of the calibration. So here we see this is much better for the method MPLSR. And this one, RPT compared to this one a little bit lower, but compared to the standard error actually is better, and also collision coefficient is higher. So basically, this one's picked. And for MPSR, many wavelengths are required. For MLR, here is 1, 2, 3, 4, 5. 5 wavelengths are required. And so two methods, they have advantages and disadvantages. And for application in the future, maybe hyperspectral imaging not needed. And so there are multiple wavelengths are needed. And then this 5 wavelengths or 2 wavelengths, this is also pretty good and could be used. Okay, just let you to make a comparison. And so which one are you going to use? MPSR, MLR? I think both of them are good. Depending on the situation you're going to apply, okay? So selected wavelengths range for two models are similar. But the results of MPSR model is better than MLR. And few features were imported by MLR model. So that's what I mean. Few means there are only 5 wavelengths, and that one is many. Okay, now you see pictures here, A, B, C, and D. And here is the very close to black tea. Here is very close to green tea. Okay, and that's so-called shooter color presentation. So I use the red to indicate a higher degree of tea fermentation. So it's red, it's 100%. It's green, it's 0%. So you can see from the color to see the degree of fermentation from the pictures. Okay, for example, the A here is 0 degree. Although you can still see a little bit of the red colors, but most of them are green. And for the D point of view is 97%. So you see most of them in the color of the red. Okay, so that's the spectral imaging purpose. So you not only get the information of the degree of tea fermentation, but also you can see visually by your eyes, because the image also is a spatial information, two-dimensional spatial information. Okay. All right. So that's what we have now. Any conclusion that we just mentioned? Okay. So any comments? Okay. How much time we have? We up to 11, right? So it's about so. I would like to show you 2 movies, but all than a short movie. Let's see. I'll show you very fast. I know time is not enough, but all the PowerPoint are on web. I just want to show you very fast about how to do the remote sensing system for greenhouse production using RFID integrated. You know RFID? You know RFID? You have this car for the subways. There's RFID inside, so you can store your money inside, and then you can deduct when you take the subway. Okay, so RFID can be used at any places. This is one of example, and most important thing I show you remote sensing from the greenhouse production. I will go very quickly because the major parts I wanted to show you the movies. And precision agriculture is site-specific cultivation. For field crops, use the satellites and GPS. But greenhouse, there's no satellites, there's no GPS. So we need to do something else. Okay, from farm to greenhouse. Nowadays, more and more crops are growing in the greenhouse, and they are important also. So in greenhouse, for sensing data, we need to use the ground-based sensing because there's no satellites. And there's no GPS in the greenhouse because it's impossible to receive GPS signal from the satellite. So we use the PLPS, Precision Local Precision System. Okay. And RFID could be any kind of form. You will see here many kind of different design and color and shape. Okay, and see the nursery. Okay. All right. And so we had remote sensing monitoring of greenhouse operation and productivity, production traceability. Okay. VRSS is a variable rate, a spraying system. Okay. And they are need a database for the system. And that's a typical example of the crop production measurement system. Sorry, I'm running very fast. So there's a multiple spectral imaging system here. I say hyper is many wavelengths, but multiple is a few. Here, only 2 wavelengths. I use 2 cameras. Actually, there's a filter in front of the lens. 2 wavelengths. Okay. Okay. And positioning system. And the image could be stitched. And then to calculate PLAI and NDVI indices for the prediction. Okay. Okay. The data, the environmental data you measure in the greenhouse, use the boom system, and you can get a whole bunch of them. And that's helpful for the growth information. And you need to mapping them together and to see what we can get. Okay. So different temperature zones, different treatments. So the split of the precision agriculture. All right, water management decision. And here we have the 5 levels, A, B, C, D, and E, and you will see different location. You may be irrigate different amount of water. Okay, all right, and I think that's the last page already. And the main purpose is to show you the one movie. This use the UAV cruise in the greenhouse to collect the temperature, humidity, and lighting informations, all the greenhouse. Okay. Just released, very new in this month. Those are anchors. Those are anchors. So you know the location on your computer monitors, and also temperature, humidity, and lighting. So you see the distribution of temperature, humidity, and illumines very uniform in the greenhouse. Okay, that's it. So that's just released because we have the exhibition next month, and I was asked to have some demonstration in the exhibition, and the movie was made for this purpose. And believe it or not, there's a movie made by my student. So I'm not very professional, but it kind of professional. You will see the quality pretty good, and so the last movie just show you that nowadays, because we have new tool of UAV, I mean that UAV to cruise in the greenhouse to collect the information of the temperature, humidity, and lighting condition. And nowadays we use the boom sensors and then go and then take the whole bunch of the information back. Now use the not airplane, UAV, and then we can do the same thing and much easier. And so just one, I would like to say, technology is advanced, and then we need to use the most new technology to make application to bioindustrials, including agriculture. Okay, so I think the time is up, and actually I have second movie, but maybe show you next time. And that's about robotics. It's a very good movie. When I was a department chair some years ago, and then that's Du Jianhua Jie. It's a festival in the university, and then we make the movie regarding the robotics. Okay. All right. So any questions at the very end? If not, I think that's all for today's class. And so thank you for your coming, and see you next week. Okay. Bye bye.
跟波轮跟首尾和海涛。